continuing our exploration of nomenclature of carboxylic acid derivatives, we see that we're going to name esters and amides. Esters end with ATE. Esters, as we've seen many times, have a carbonyl, an O, an R prime. And you got to know this part comes from alcohol. And this part comes from carboxylic acid. And the name always ends with ATE. End. So formate means this was the carboxylic acid. And we know that to make an ester, you have to replace the H on the O, which I didn't draw because I'm about to replace it, with the R from the alcohol. And R here is isobutyl. So esters, they're named as if they're ionic compounds, and we name the anion second, right? That's the formate ion, would be an O- ion, and we know it's not an ion, that's a covalent bond here. It's far from ionic, but it's named like it's ionic. So the anion is the formate, the cation is the isobutyl group. And that's easy, huh? And then amides have R carbonyl, and you guessed it, that's from the carboxylic acid, from Ca. Carboxylic acid is Ca. And the other part, N, R prime, R double prime, from an amine. An amine. And we don't know how to name amine, but we don't have to. If there's a group on nitrogen, you just tell me there's a group on the nitrogen. Look at the example we're looking at. It says on the nitrogen, there is an R-sec hexyl group. Yes, that's what the scripted N means, attached to nitrogen. That's nice. Okay, beautiful. Let's go with it. We're going to draw heptanoic acid, but we're going to lose the OH. Here's the heptanoic acid. It's got the O. No, we're going to lose the OH. Don't draw the O. Draw the carbonyl. Six more carbons. 1, 2, 3, 4, 5, 6. That gives a total of 7 carbons. And that's the amide. If you put a nitrogen here, and you're going to put a sec hexyl on there. Sec hexyl, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Good. And it's a stereocenter that has to be R. That puts the H on a dash, methyl, or the nitrogen bond on a wedge. And students have found out the hard way on tests that if you leave your answer like this, then you will lose a quarter point. Rules of stick figure. You're only allowed to omit H's on carbon. This nitrogen only has 2 bonds. This is not a normal nitrogen. It's a unicorn. It has a H. You're not allowed to omit that H. Okay. So the next one, he said, hey, esters end with 8. Oh, this one doesn't end with 8, it ends with ite. Phosphite. just a little note, 8 ions from ic acids, ite ions come from OUS acids. Huh? So, we have an ite ion.
Yeah, they used to have like an expression to help with this in Chem 142.
I got one in 241 if you want to share. She says in 142 there's an expression. I wonder how close it is to my expression. What's your expression?
For the 8, I ate picky food. And for
I ate picky foods. I like it.
yeah, and Sprite is delicious.
Bright is delicious.
Right.
Sprite is delicious.
Yeah.
Okay, I like it. It's interesting. I ate picky foods.
Picky.
Icky food.
Yeah.
8 goes with ick is what the
Yeah.
sense is, right? Mine is shorter, and it sounds like medicine. Attic-itis, like attic in your above in your house, the building, the room above your ceiling. Okay, attic-itis. 8 ions from ic acids is attic. Itis, like a disease, I-T-O-U-S. Ite ions from OUS acids. Attic-itis. I'm gonna write it down. And in fact, somewhere, I think in the 241 book, I wrote it the acid naming disease. It's in there. Okay. This one, you need phosphorus acid is what I'm trying to say. Phosphorus acid has one less O than phosphoric acid. Just because 8 ions have one more O than ite ion. So phosphorus acid, if you look on your previous page, phosphoric acid had the 3 OHs. Phosphorus acid has it'll be H3PO3. Did I say one less O? I hope I did. Yeah, good. So this is H3PO4. And when we do this one over here, we're going to do H3PO3. And that'll give P. Oh, sorry, I'm not going to have room for my answer here. There you go. That's phosphorus acid. So draw everything with the 3 O's. And how many ethyl groups? 3. Each H has been replaced, so it's a triester. There's your final answer. And why do you think he picked that particular example? He picked that particular example because it was on the test you just got back. Yeah, we use those in the Arbuzov reaction to make the Arbuzov reagents. Now you know that those are phosphite esters. Okay, we didn't know that before. And down here, we're going to do a sulfuric acid amide. But not really a sulfuric acid, it's a sulfonic acid. Oh, sulfonic acid. Sulfonic acid. R is attached to S-double-O-OH. Yeah. Seems like I did a huge quantum leap there, but when we start talking about sulfonic acids in chapter 4, I expect you to kind of be able to brush up on it pretty fast. Yeah. Toluene sulfonic acid has a toluene group. There's R. That's one of our 7 strong acids. 7 strong acids. Sulfonic acid has become a sulfonamide. How do you make amides? Well, there was an ic acid before this thing became an amide. I got rid of the OH and put what in its place? Nitrogen. Get rid of the OH and put nitrogen in its place. We better make a benzene on the sulfur, because it says there's a benzene on there. And what does p-amino mean? This benzene in the para position has an amino group. That's an NH2. That has nothing to do with a sulfonamide. That's a group on the benzene, an amino group. And is there anything else in the name? There's nothing attached to nitrogen in the name. So if you want to lose a quarter point, leave it like this. Otherwise, remember, nitrogen has to have 3 bonds. 2 H's missing. That molecule there has a historic consequence that dates back to World War II. Yes. There was a lot less deaths due to infection in World War II because this is the first antibiotic ever used in the battlefield. This particular drug right here. It still has uses today, but approximately 10%, maybe a little higher of the population is allergic to sulfa drugs. And that's their name, sulfa drugs. One of the earlier antibiotics, or earlier synthetic antibiotics. Okay. So what do we have here? Are these the same molecule? Did Dr. Whitaker make a mistake? No, he did this on purpose to show you the direction you type the CO2 is very important. CO2 that way means the carbonyl is on the right of this molecule. Then 11 CH2s after the carbonyl. 2, 4, 6, 8, 10, 11, and then one more. And then the O is here. And down here, the CO2 goes this way. So this is just a 12 carbon group here. 1, 2, 4, 6, 8, 10, 12. And it's attached to the O. Okay. And I'm just redrawing the molecule here. I'm not naming anything. Expanded some of it and shortened the other part. Good. And here the carbonyl is on the left. CH2 once, twice, F. So the ic acid on the top is in green. Dodec and O. What happens to the end of the name? Well, let's go back to formic acid becoming formate. HO, carbonyl, formic acid. What happened to its name? You kept the form. Ooh, I went too far. Just the FORM, huh? And this one, formic acid. This one used to be dodecanoic acid, and it became dodecanoate with a group on it. A group on the O called a 2-phenyl ethyl. Make sure it's clearly 2 words. Yeah. And this one, whoa. Whoa. This one ends with 2, well, hello. 2-phenyl. 1, 2, 3. 3-phenyl. My apologies. 3-phenyl propanoate. That's all one word. I want it to be very clear. It's one word. Prop and O8. And the group is a dodecyl group. Yeah, Back to amides. This is a carbonyl on the left, nitrogen on the right. Carbonyl goes to a C with one H. Oh, I got an octet violation on my own activity. Oh. Please get rid of that H. It has no business there. That was 5 bonds to carbon. Shame on me. There's 3 propyl groups attached here. 1, 2, 3. 1, 2, 3. 1, 2, 3. There you go. So the longest chain with a carboxylic acid, it's a pentanamide. How do you know it's a pentanamide? Well, previous example says you change ic acid to amide. Ic acid becomes amide. I'm just going to write that down. Pentanoic acid. Oic acid became, normally we keep the O. Pentano. I will just note that I will accept the O before the A because usually we keep the O. The only reason they got rid of the O is they didn't like how it looked. Okay? I'll take the O before the A, right here. Or I'll even be very clear about it. Pentanoamide. Pentanoamide. In my books is perfectly fine. The people at UPAC give you a little trouble. OWL would probably give you a little trouble. But I follow the rules a little better with a red one. And what about my group situation? How many propyls are in this molecule that are currently unaccounted for in this name? This propyl is actually part of the chain, so that's no. But there's a propyl there, a propyl there, a propyl there, a propyl there. 4 propyls. Tetrapropyl is in the name. Tetrapropyl, all one word. Tell me where the 4 propyls is. I need 4 designations. Normally I would have said I need 4 numbers, but we just learned how to say the groups are on nitrogen. Treat those like just like numbers, but they're a letter. So you're going to say one of them's on N. A second one is also on N. A third one is on 2. A fourth one is also on 2. And why did I write it down there? I have no idea. Oh, give it to me, buddy. You're being mean. Make me move it one little piece at a time. You won't even give me this one. There, finally. Groovy. And down here, oh, what is this? This came from phosphoric acid. Just a reminder, phosphoric acid becomes phosphoramide. Now tell me what's not phosphoramides. Well, there's a group on the nitrogen. We know how to say that. N allele is one of our common groups. You could write N2-propenyl But allele's a lot shorter. And phosphoramide. And there is a way to say that 2 of the H's have been removed from phosphoric acid. And I don't believe I've put this in any publications or videos previously, but it actually is pretty straightforward. Add a word at the end. Dibasic. That makes sense, right? 2 of the acidic protons have been removed from phosphoric acid, and now you have their conjugate base O minuses, right? So it's a nice little nomenclature trick here. So you can say dibasic. There you go. That's your final answer for that one. That's the final answer for that one. Here's the big picture. Moving along. Okay. Next activity after a break.